Here we are at example 2 from our 2.1 set of notes. We're asked to find the tangent slope from our warm-up. Now, the function that we were looking at in the past was y is equal to x squared plus 1. And we were looking at it particularly at this point 1, 2. And so we're hoping to find the tangent slope at this particular point 1, 2. So graphically what's going on is we have our function doing something like this, and again at this particular point, this target point 1, 2, we're looking for what is that tangent slope. Well, we actually already did go ahead and find the tangent slope, but for right now we're trying to actually prove what it was. So we know that the limit, our tangent slope, is equal to the limit as h goes towards 0 of f of a plus h. Again, this is that target x value plus some distance away from him, minus our f of a, in other words, the y value for our particular target point, all over h. So pretty much just that distance from our target point to our other point. Going ahead and, again, throwing in this a plus h. Actually, we'll go ahead and throw in our target x value. In this case, a was that target x value, being 1. Then we have the limit, as h goes towards 0, of f of, again, a was 1, because that was our target x value, plus h minus f of 1, all over h. So again, pretty much there, just throwing in the target x value. In this case, it was 1. Now let's go ahead and throw in this 1 plus h and 1 into the function. So we have the limit as h goes towards 0 of our function. It was 1 plus h. That's what's going in for x. And that x is being squared plus 1. So again, just taking this 1 plus h, throwing it into our x value for our function, and then squaring it and then adding 1. Minus our f of 1. So going ahead and throwing 1 into this function. When we do that, we have 1 squared plus 1. And on the bottom, we still have this all over h. So again, we were just taking these values, throwing them into the function. Now we have the limit as h goes towards 0 of, I'm just going to go ahead and rewrite this 1 plus h quantity squared. I know that some of us are good enough that we can actually go ahead and FOIL it perfectly fine, but I kind of want to show every step, especially for these early limits. But if you're confident you feel like you can go ahead, then please go ahead. 1 squared is 1 plus 1 just comes out to be 2. And this is all over h. Then we end up with the limit as h goes towards 0. A lot of this is really just algebra, so if you're good with that, you should be pretty decent. Just going ahead and foiling this, we have 1 plus h plus another h gives us 2 h's. H times h gives us our h squared. And then we have our plus 1 coming from here. Minus 2. All over h. So then we end up with the limit as h goes towards 0 of 2, because 1 plus 1 gives us 2, plus 2h plus h squared minus 2. And again, this is still all over h. We then end up with a limit as h goes towards 0 of going ahead and subtracting now. We see on top that these 2's are the only things that can go ahead and be subtracted. So those are actually gone now because we had 2 minus 2. Leaving us then with 2h plus h squared all over h. And now we can go ahead and factor out an h. The reason why we can't go ahead and take this limit is you get that 0 over 0 indeterminate form that we talked about in the first chapter. And so unfortunately that's not going to quite work. So that's why we're trying some like algebraic techniques to simplify this limit. So we end up with the limit as h goes towards 0 of h times 2 plus h all over h. We see then that they actually do cancel out. And now we can go ahead and take our limit using that direct evaluation. So we end up with the limit as h goes towards 0 of 2 plus h. Going ahead and throwing this in, we see that that tangent slope comes out to be 2. And this actually confirms what we were seeing back from our warm-up, especially the warm-up continued, where we were looking at that x value that was incredibly close to that particular target x value, 1. We saw that slope, I think it was going to like 2.0001. But again, it really gave us a very, very close slope, and this is the true slope that is tangent to this curve, y equals x squared plus 1, at this particular point 1, 2. And there we can even see it. It is going upwards positively, and it has kind of a steeper slope like 2. So it kind of even matches graphically. Again, that is example 2 from our 2.1 set of notes.